CASA this morning. We're glad to have you all here, and glad to be part of this group. We've got some new faces this morning. Glad to see that. And I guess we'll start off by
students.
Yeah.
Oh man,
You've been busy.
all right.
Do you want to kick this off? How do
I
you
would
want to do
like to say a
this?
little bit. Hey, so this is Central California Diagnostic Club, and this began. This is our 75th workshop. We started January 1st, or the first Saturday of
Was I
January.
supposed to buy like a
and
diamond
19.
for everybody or something?
Watch.
So we've been really consistent. We've only missed 3 times out of that. And so this diagnostic club, there are 2 components, as you can see right now. We are tech to tech, or industry to industry. We're working with other shops, we're working together. And so we share everything as we learn something new from the previous month. We come here and we do case studies and we share. But the other part of it is industry to education. And so we have 2 different things that we do, and that we've been doing it for a long time, and we go to a lot of career fairs and things like that. So anyway, we have, you guys don't know this yet, Napa, we have an invitation to travel to Visalia in the near future to see if we can help the guys down there. But that's what we are. We are a bunch of owners, techs, and students, and we all share, huh?
Educators.
Educators, yeah. And we have 2 educators here, and so we have industry right over here. We have Napa, we have O'Reilly's, and so anyway, we're trying to build something. We're trying to build a model that somebody anywhere else in the United States could come and ask us, what are you doing? We would like to do this here. And our biggest thing for me is what happens is when you have shops, and I don't want to say anything too bad, but sometimes we get cars that have been here, that have been 3 other shops, okay? And then they come here, and the reason why, and I'll be hard, is because shop owners do not provide their technicians the training and the equipment that they need. And if you don't have that, what's your choice? Trial and error.
Shotgun approach.
Trial and error. And that brings our whole industry down. It brings us all down. And what we've been trying to do is elevate our industry. That's why you see peer-to-peer or shop-to-shop. We also need you guys to come into our industry and help us out because it's growing. And so that's the industry to tech part. Okay?
Yeah, it's a 608.
R90, yeah.
In park, everything's fine. You can rev it up. Everything's normal. As soon as you put it in drive, engine bogs down, like you're power braking it. You're like, oh, it doesn't want to do nothing. So we got an in-cylinder, and we have a intake vacuum, another one on the vacuum side of it. In part, we got about 76 compression. As soon as it goes in drive, compression spikes up about 120 something? 122.
Just putting it in drive.
Just put it in drive. It spiked up there and
That's within our. Engine vacuum. And our engine vacuum, we're doubling that. We're at about 12 inches of vacuum. Like the all the open. We're gonna look at this one in part. pretty normal right there for park. But once you put it in drive, then he was getting, like you said, it was like something with power breaking, possibly thinking something internal with the transmission because it's only going from park to drive, and then all of a sudden the vacuum changes. I think the computer's trying to compensate and opening the door.
Yeah, computer was opening the throttle. It seemed like the torque converter was locked up already. As soon as you put it in drive, torque converter locked, and that was causing that issue. It was pinging, bogging, just like you had it, like you were kind of power rating everything.
But not moving.
But yeah, we're not moving, so.
Yeah. That's pretty good.
That was an interesting one right there.
Okay, so we got a 2005 Ford pickup, F-150. This car came in for a string engine light. It has, I say it has because it's still at the shop right now. It has those codes right there, the 340, the field 340 camshaft position, circuit, right? So that's the definition of the code of this track. So after doing a little bit of research, doing some visual inspection on it, we found multiple things that they have replaced. They replaced the camshaft sensor. They already put a nice zip tie on it. It doesn't go away. They replaced. We saw this. I don't know why is it replaced, but it's the throttle body, oils. So one of the things that we did, it's right away we scoped the camshaft position since sometimes the code, the definition of the code is in a lot of cases not even true. The code says it right there that it's a circuit problem. Right? So sometimes the definition of the code doesn't really mean it's a circuit. Right? The computer thinks it's a circuit, but in reality, this is what we can actually see on the.
Can I ask you a question? Since that's Ford, it has key on ignition off, and key on ignition on, right? So if it's a circuit, if you're running on key on ignition off, nothing's running, and you're running key on ignition off, and it has a bad circuit, can you confirm if it's a bad circuit and key on ignition off? I mean, that's what I want to do. I was just wondering what you think.
I think that would be a good advantage. We don't really use that feature of the PR.
Oh, you don't?
We didn't use it, but that's a good idea. That is a good idea.
Is that right, Scott?
Depends on the problem. Depends on the problem.
But I mean,
It might show up when it's off, it might not show up if it's not on the load. The problem happens when the circuit's being loaded. The PCM's not working, or where the module's not running while loading on it.
but it runs a test when it's not running, so if the code shows up then, it's
Yeah,
something,
it's probably
right?
definitely.
Am I right? You're the Ford guy. Why would it need to be loaded if it's a sensor? Huh? It was the Ford guy 40 years ago. 7-time national champion. Explain that, I'm lost, I need help. I know, but if it's open or closed, I mean, if it's open.
Okay, so this is the actual waveform from this code. We got the crank sensor, we got the both cam sensors in here. Working with Fords a lot, right away we recognize that this is a problem. These two little bumps right here, they're not supposed to be there. They're not accurate, right? So we're supposed to have a nice, consistent waveform like these. So we saw these little two guys right here. We were like, what the hell is that? So right away we know that we're not dealing with the circuit problem. The signal is there, it's just that the computer doesn't recognize the signal, so it throws out these other codes. We can see the crank sensor, and we can see both cam sensors here. So this is the actual waveform that we took at that moment. I just want to point these out because this is a problem right here. Okay, I'm going to show you what a good one looks like. So we went to the library.
Those two little humps happen every time, or you was it already?
Yeah, they happen every time. So it's a hardware problem. So if we go back to the other waveform, then just going back to different waveforms, and they're there every single time.
Same spot.
Yeah. Good question though, because you might wiggle the wire and
Yeah,
go away,
it
right?
might be gone.
Yeah, that's good thinking. So it's exactly the same pattern over and over. So I went to we went to the library. I can't remember if we saw this in the library or in the website box. So you guys use that, Roki?
Yeah.
Okay. So that's where we found this at. This is an actual good waveform from that track. And what we saw right away, we said, okay, this is the crankshaft, and these are the two camshafts. And you can see that they're absolutely different. We don't have those small bumps as the other one. This one has the 3, it has a 3 over here, and ours has this. You guys see the difference?
And it was just on one bank, not that other one.
So right now, yeah, so right now we notice it here. We can see this right here. This is not normal either. These two right here, they're supposed to be 3 big ones. And right here, they're supposed to be 3 big ones.
So both banks are getting the same erroneous information.
Right. They have inaccurate data on the gas sensor. So
So you say it's still at the shop, you throw cam sensors in and what happened? No?
no, we didn't throw cam sensors because this is not a circuit problem.
Oh, the cam, the rocket,
Well,
the reluctor.
we took off the cam sensor, we throw in a boroscope, we turn the engine, and that's the phaser right there. That's part of the leg of the reluctor from the phaser. It's broken sideways. Did you guys see that? That's with the boroscope. I'm taking a picture of the screen of the boroscope.
Something hit it.
That's how you do it. We've seen that waveform repeatedly exactly at the time. It's a repetitive.
I don't know what, this truck, with all the new components and zip ties and everything, I don't know what the hell they were doing with it, but we're gonna find out. I still have it at the shop. They just authorized the teardown, so once I find that out, I'm gonna post it and share it with you guys what we found, because this thing has been manipulated.
Right. So this is the same thing that we ran into with that Honda having the wrong amount of teeth. It's about information to the computer. When the computer's not, it's trying to speak English and it's being talked to in Russian. The computer does not understand. It sees the information, but it doesn't understand it. So that's something that, as techs, we have to make sure that we don't overlook.
And this is what gets a lot of people confused, this right here, the circuit portion of the definition. When I look at this, I don't even look at that, I look at the code. Punch it in the code, let's see what the condition setting the code is, so that way we can go after the test. Adam taught us how to, this is a test. This is an actual test that the computer is doing. Okay, at this moment I gotta run this test, and if it fails, I'm just gonna set the code, and I'm gonna draw the light. It's just a test.
In this case, it's setting the circuit because it doesn't understand the information.
It doesn't understand it, right? So that's why we set up
Because
the
it's a
circuit.
code, because it's not diagnostic.
Right. Yeah, I remember Falco.
Can centers though. I said, I was on with two can centers.
You know, now that I'm thinking that the test that you were talking about, Keon, I think it would pass. Why? Because it's just doing an integrity test of the circuit.
Right, exactly.
That's all it's going to do. It's going to have the key on. It's going to go to the sensor. It's going to come back. It's going to say, bits up. You know, it's good. It's good.
That's right, you would have known that.
But once that it's running,
Really right.
now that it's running, it's not going to. That's it.
This is running here, no problem, right? That's not a big.
That's running.
So how does it work?
That's not running. Jack, but it's not.
Yes, it does. That is. That's why it kept tapping into T. It's such a simple design. You can set it. Because if it could have set it circuits or something like that, man, it defaulted to me from that's the cable so big.
I don't know where I'm at.
So, in this case, there's information.
No, that's not even the problem. I just mentioned it because it was big that's going to be a really hard engineering question.
Well, I used to do it for license.
What Mike's talking about is that the computer doesn't see the whole waveform. It sees a decision point. It sees, the computer just sees that. Let's just say that this is a waveform. It's just going to see a little small portion. Like, let's say this waveform. It's going to see that. It's going to see a little, what Mike said, trigger point. A little, okay, this is where it's at. This is when it went up, this is when it went down. This is when it went up, this is when it went up. That's just a little trigger point. That's what the computer sees. It doesn't see the whole waveform. Now the problem is that let's just say that this particular waveform, the trigger point is right here in the spot. Well, this one didn't make it, so that's why it didn't see it. And it's a circuit code. It doesn't recognize the signal.
It's a real important concept for intermittent diagnostics, where you got a problem all the time, that doesn't mean you have a symptom all the time. So you can see the problem that it's not big enough to trigger a symptom, but it's going to at some point, and that's when the intermittent problem occurs.
Yeah, so my biggest takeaway here is that the circuit, the definition of the code is not always accurate. You know, when they write these things up, they just write them up, and sometimes it will say performance, and it's a circuit problem, or the other way around.
They're engineers that.
2019 Nissan Pathfinder. This one came in for had a bunch of lights on: ABS, traction light, collision light, the ADAS lane departure light, all those lights were on. Brake light, anything has to do with the traction system and the ADAS, they were both, all those lights were on. Christmas tree. So we scanned it. These are the codes. This is the ABS module, by the way. It's sending these codes. It's the U1000, which means there's a problem with network communication. I don't like someone. That's the ABS saying that, and the yaw rate sensor. So sensor that is responsible for telling the angle of the vehicle. So after a little bit of research, a little bit of test, research, we found out that the rate sensor is integrated with the ABS module. It's part of the module itself. So we decided to look at the waveforms from the CAN communication through the DLC. And I just want to point something out real quick because this is something that we're going to be seeing a lot. A lot of cars right now, they have gateway security modules that are part of the DLC, right? So when you hook up the scanner like Dodge, you need a special license to talk to the car. I see the head, see that, yeah. So those systems have a security module, which means that you cannot talk to the car unless you go past that security system, right? Which means that if you hook up this box into the DLC, you're gonna see nothing. Because that's how a lot of times we are diagnosing these cars, we hook up to the DLC and we're looking at all the communication going around the car. Well, something like this, Nissan or Chrysler products, they have a security gateway, so they don't let you go past that unless you're talking in a generic SCANTO. We scope it with this, nothing, just flat 2.5 voltage, nothing. There was no activity, but the car was running. System, and we notice that the power steering module, which is right here, the ABS module, it's back over there, somewhere back over there. So we're not getting to that module. Looking at the diagrams, we notice that the same communication goes to the power steering module. Because on CAN system, multiple languages, multiple speeds of CAN system. So we have to find out which one. If you're going after the ABS, we have to find out the bundles that circuit into that CAN, because we have different ones. So we realize that this guy right here is bundled in the same circuit for the ABS, so that's where we attach to the power steering. Setting the code, that's the only reason. And it's setting a yaw sensor code. By the way, the yaw sensor, when we were driving the vehicle, it was actually reading the yaw sensor information. Because we can still talk to the ABS and everything. It's just that for some reason, the ABS was capturing the data, but not sharing it properly to the rest of the system. Corrupting it, exactly. So, if you guys use this, and which is a really, I cannot see of any other way of diagnosing networking problem other than this way. But if you guys go into one of these, it'll actually take you to the package that the computer is seeing, and you can analyze it. If you want to go a lot deeper, you can actually analyze.
It'll take hours to go through it if you don't.
It'll take tons of time, yeah. So for some reason, the computer doesn't like this section. And if I go to another one, for some reason the computer is gonna like this section. I can see a problem right there. That's called a conflict. Two computers are trying to talk to, at the same time, and they can't, so they're overlapping each other.
So when you hooked up the ABS module, disconnected it, what happened?
So, we disconnected the ABS modules just like Warren's talking about. That's our signal. We go back to the scope. Actually, the signal I'm going to show, it's actually with the new ABS. But we disconnected the module. It's going to look really similar. This is actually with the new ABS module, or actually a usual. But if I go here, the same decoding information, very little. Because sometimes, they do generate that. Right. But when you have a whole capture of information like that, and a quarter of it is invalid information, that's a problem. At least that's what we have seen. Has someone else seen something different on that?
I know that sometimes if you have like one in the red, one that's flagging, you put it on it, it didn't capture the whole thing. It was only part of the transmission.
Oh, that's right, yes, yeah.
And then therefore that software detects it.
Gotcha. That's the scope. That would be a scope problem because it didn't capture the whole package. Gotcha. Makes perfect sense. What Gil was talking about is you might get some reds on the scope because it didn't capture it. It was cut halfway, so it didn't capture it. So that's a really good point. So on this one right here, all a bunch of greens. Let's go for it. If I click here, I can see if there's any embedded information. There's nothing in there. So on this particular one, that fits. We replaced the ABS module. That fixed that problem. That problem. Got it fixed, got it programmed, took it for a drive, no codes, no lights, everything was cool until 2 weeks later, or like a week later. Customer came back, but this time only with the collision light on. Not the ABS, not the traction light, just the collision light on. So we check it again, that's the module that we replaced. This time it had these codes. Laser beam off center. This is the radar module. The one in the front of the car, the one that's detecting the this is a radar sensor, the one in the front. When we talked to this gentleman, I talked to him personally because when I came back, I get more involved with the customer and kind of try and get more information. He said that he had, before he took it to us with all these problems, he took it to the dealer and they tried to do the calibration on the radar sensor. Obviously, that wasn't going to be able to get done because he had a problem with communication. That was not going to be possible. So when we only had this code, we knew that there was a problem with that system and not the traction unit because we didn't have the U codes anymore. We didn't have any of those problems.
So Nestor, these were unrelated, they were just a couple of code things that happened at the same time? The ABS module went down.
Were those codes driving in a different module initially?
I'm sorry?
Did you see those codes in a different module initially, or were they not?
We had codes on the radar sensor the first time, yes.
First time, yeah.
Yes, but we attach everything to the communication because the communication problem sets a lot of different codes. When we were done with the ABS, we basically drove the car, no codes, no nothing. We actually even tried the ADAS and it was working just by trying it on the road. And it's just stable, and that's what I'm going to cover right now because I'm going to go more in depth on the ADAS. It worked fine and there was no codes. But after the gentleman was driving for a week or two, he said that code. So when we scanned it, now this particular code wasn't there before. The ADAS was saying that it had a problem with communication. The ADAS was also saying, I have a problem with communication. But this code wasn't there before. This one was set after the gentleman took it and then he brought it back. And then that's when he said, yeah, I took it to the dealer. They try and do the calibration. I don't know what they did. So take the bumper off. Do all the ADAS calibration. On these, you have to get to the module, to the sensor. There's a procedure for it. When you start doing ADAS, there's a special procedure that you have to.
Is this the machine you bought in Vegas?
Yeah.
You already bought in Vegas and you already got it going? Okay.
So that thing shoots out a laser, and it's supposed to center right there. There's a little mirror right there. That's a mirror that comes with the ADAS, and it shoots back the laser. And you're supposed to pretty much center it in the middle. It reflects back to the mirror. And you're supposed to pretty much center it in the middle. But see that laser right there?
I'll set it.
Yeah. So we adjusted this, because it was off. Let's see if I got some picture.
It's a physical adjustment.
Yeah,
This is a static adjustment or dynamic?
static.
I know, I'm just,
Yeah, but we have to, I'll show you guys a video. But basically when it came, I don't have a picture of it, but basically when it came in, we measured it and it was 85 degrees. 85 degrees off.